Hi everyone! In this video I'm going to do the solutions to the two examples at the end of the product and quotient rule section where we're using more than one derivative rule for the same problem. So my first function here is 3x plus 5 over x squared e to the x. Alright, so this came with a little bit of a hint, which was start by using the quotient rule. So I can tell, even without the hint, that I need to start with the quotient rule here, because what I'm looking at is a giant fraction, right? Like the big picture here is some stuff divided by some other stuff. So that tells me the quotient rule is kind of what I've got to start with. So my top function, f, would be 3x plus 5, and my bottom function, g, would be x squared e to the x. Alright, so I'm going to write out those two decisions here. So, okay, f is 3x plus 5, and g is x squared e to the x. And now I need to compute the derivatives of both of those choices so that I can put together my quotient rule formula. Alright, so if f is 3x plus 5, its derivative is 3 plus 0, so I'll just write a 3. Now, the derivative of g is where this starts to get a little weird, right? So I don't have a derivative rule for something like x squared e to the x. It's not like its own rule from last class. What we have here is clearly the product of two functions that we have rules for. Right, x squared e to the x, I don't just have a thing, but x squared I can do, e to the x I can do, and this is those two things being multiplied together. So I'm going to realize that this is the product of two things whose derivatives I have rules for, and so what I'm actually going to use here is the product rule. So I'm going to switch to a different color here and organize. So this will be the product rule where the f of x is x squared and the g of x is e to the x. Because this is those two things multiplied together. So I need to compute those two individual derivatives. The derivative of x squared is 2x to the 1, so I'll just write 2x. The derivative of e to the x is, again, e to the x. Alright, so for g prime, red g prime, I'm going to use the purple stuff here in the product rule. So I'm going to have f of x times g prime plus g of x times f prime. So f of x, purple f of x, times g prime plus g of x times f prime. So I had to use the product rule to get this derivative. But now that I have it, I have all the pieces to do the quotient rule, which was kind of my overall agenda. So I'm going to take all this stuff together and put it into the quotient rule, which of course is g f prime minus f g prime over g squared. That's my kind of shorthand for the quotient rule here. So in future calculus classes, it is going to be important that you know this off the top of your head. But keep in mind, while we're online this semester, you'll always be able to have this formula in front of you written down, so don't stress memorizing it just yet. Just worry about, or start to practice it more and more. Okay, so I'm going to use my red f and g here in the quotient rule to get the derivative of my function. Alright, so I have g times f prime minus f times g prime, and then g prime is this whole piece here in parentheses, all divided by g of x squared. Alright, so this looks bad, right? Like this is a really complicated function, but we're not going to worry about simplifying it. We're not going to worry about expanding any of this out. We're going to leave it how it is and say this is technically the derivative, even though it doesn't look pretty. So this right here is my answer for the first example. All right, now my next example, if I can move my paper up here, is 10x cubed plus 1 times the square root of x times e to the x. So here I have essentially the product of three functions that have derivative rules, right? So 10x cubed plus 1, that I could have done the derivative. The square root of x is really x to the 1/2 power. That I have a rule for, and then e to the x I could do. But because they're all multiplied together, this will get a little bit complicated. So I'm going to start by saying this is a product, right? This is something times something. So the way to do this is to sort of glue two of them together for now and then deal with it later. So what I'm going to do is the product rule where this is f and this is g. So when we go to do the derivative of f, we'll have kind of some extra complications, but at least this is technically the product of that times that. So the product rule should be kind of the overall rule that I'm using. All right, so f of x, I've decided, is 10x cubed plus 1 times root x. And g of x is e to the x. So my default when this happens is always to just take the first and second functions together and then let the third one be its own. But you would get an equivalent correct answer if you glued these two together as g and then had f be just the part in parentheses. The answer looks a little different at the end, but it would be just as correct. So it was sort of a random choice that I made here to take these two together. All right, so at least for g prime, if g of x is e to the x, I know g prime is also e to the x. That's a nice rule. But for f prime of x, I say, oh no, I don't have an automatic answer for what the derivative of this function is. But I want to realize what I'm looking at is the product of two things that I could handle, right? This is one function times another, where I could have done the individual derivatives. So because these two are being multiplied together, I can see that I'm going to need a little product rule just to get the f prime here. So I'm going to set up for my product rule in purple. So the f of x is 10x cubed plus 1. And the g of x is root x. Right, so now I have to compute the derivative of each of those, which I can do in a single step now. So 10x cubed plus 1 will give me 30x squared plus 0. Remember that the square root of x is x to the 1/2 power. So its derivative is 1/2 x to the negative 1/2 using the power rule. So this is nx to the n minus 1 here. All right, so I'm going to take these pieces and use them to get red f prime here. So I'm going to put them into the product rule formula to get this derivative here. So I'll have purple f g prime plus g times f prime from the purple. All right, so now that I've done this work, I have all four pieces that I need to do the product rule for my original function. So I'm going to use the red f and g stuff here in the product rule formula for my final answer. So we'll give ourselves just a little bit more space. And we have the derivative of the original function is, from the red information, f g prime plus g f prime. So I have f times red g prime plus g times f prime, which is this whole thing here. It's not cute, but we're just going to keep it exactly as is in a big set of parentheses. So I've got 10x cubed plus 1 times 1/2 x to the negative 1/2 plus the square root of x times 30x squared. So overall, what I have, oh, there we go, we can fit it. So overall, what I have here is the product rule, right? One function times the other's derivative, plus second function times and then the first function's derivative happened to require the product rule for a second time.